Now, let's consider Bayes' theorem. Bayes' theorem computes the posterior probability that someone truly has the disease given a positive test result. The probability of having the disease given a positive test, which is written as P, disease, positive, is calculated by multiplying P, positive, disease. The probability of testing positive if having the disease, by P, disease, the prior probability of having the disease. All of this is divided by P, positive, which is the overall probability of testing positive. Now, let's find the probability of a positive test result, P, positive. To repeat, P, positive, represents the overall likelihood of getting a positive test result, whether or not someone has the disease. The law of total probability helps to calculate it. The equation shows P, positive, is equal to testing positive given disease times the probability of disease, plus probability of testing positive given no disease times probability of no disease. Now, substituting the prevalence, sensitivity, and specificity values into the formula, it's determined that the overall probability of testing positive, P, positive, comes out to 0.1085. Now, it's time to calculate the posterior probability, which is the probability of actually having the disease, given a positive test result. That is, P, disease, positive. Using Bayes' theorem and substituting the values from earlier steps, P, disease, positive, is obtained by multiplying 0.95 and 0.01, and then dividing by 0.1085. From the Bayes' theorem calculation, the probability of actually having the disease, given a positive test, P, disease, positive, is approximately 0.0875576. A rare disease affects 1% of the population. This is P, disease, the prior probability of having the disease before considering the test result. The test correctly identifies 95% of people who have the disease. This is the conditional probability P, positive, disease. The test correctly identifies 90% of people who do not have the disease. This is the conditional probability P, negative, no disease. Here, the focus is on a medical diagnosis scenario, where a test is used to detect a rare disease. The question asks to find P, disease, positive, the posterior probability. This is the probability of having the disease after knowing the test result is positive. Several choices are given, and the task is to pick the one that comes closest to computing P, disease, positive. Answer choice A is 8.6%. Answer choice B is 90%. Answer choice C is 50%. Answer choice D is 95%. The problem involves a medical test used for detecting a disease. The task is to determine the likelihood of actually having the disease, given a positive test. A problem has been designed around calculating the probability of true positives in a medical testing scenario using Bayesian principles. The problem statement presents a scenario involving a medical test for a rare disease. It provides key information such as the test's sensitivity, specificity, and the disease's prevalence in the population. The question asks to determine the probability that a person actually has the disease given a positive test result. This is a classic application of Bayes' theorem. The medical test's characteristics are detailed here. Sensitivity is the true positive rate. The test correctly identifies 95% of people with the disease. Specificity is the true negative rate. The test correctly identifies 90% of people without the disease. Prevalence is the proportion of the population that has the disease, which is 1% here. Using these values, the posterior probability of having the disease after a positive test result is calculated. Here, choosing the answer means selecting the option closest to the calculated posterior probability. Got it? Option A suggests a probability of approximately 8.6%. This is one of the possible answers to consider. Option B suggests a probability of approximately 90%. This is another one of the possible answers to consider. Option C suggests a probability of approximately 50%. This is another one of the possible answers to consider. Option D suggests a probability of approximately 95%. This is the last of the possible answers to consider.